Welcome everyone to another legit coding activity. In this coding, So in this coding activity, we're going to learn how to make linked lists and learn how to make a stack. So on the right side of the screen, how many of you cannot see the screens right now? You're good. We have a description of the coding activity itself. We're going to make a stack using a linked list. For extra credit, you can make a generic stack that will take any kind of value, but in our case, we're going to make a double stack. So a stack is a container that you put things in. Think of like a cupboard or a pile of dishes in the cupboard. And here we're putting a pile of doubles on. So we put a double on top of the stack or remove a double from the stack. So let's talk a little bit about what a stack is. Now all of you have learned how to make a class. And a class is just a, whoopsie, what's this? This is erase. A class is just a box into which you stick variables and methods. Variables and methods. So a linked list will have a variable in it that will contain the value we want to hold. So in this case, we want to know what a double is. So we're going to put a double in here. And this we usually call a value. So let's call this double. Double. And we'll name it value. We're going to call this class, we're going to name it node. So the name of this class is called class node, and not only does it have a double value in it, but it has another class node in it. We'll call this next. So we have two attributes. One holds the value that we want, and the other one holds a way to get to another instance of the same class. As we make a linked list, as we make a stack, we will have a value in like 3.14, and then we have how to get to the next node. And the next node might have a 1.25 in it, and a way to get to the next node, and so on. So as you see here, I'm drawing a little bit, we have nodes. You can think of them as links in a chain. We have one chain link here, it links to the next chain link, and it links to the next chain link. In order to get access to this entire stack, let's make this one 0. The end node generally points to null. And I usually draw null as a big X like there's nothing there, or I'll draw a 0 with a line through it, null. At some point, the next pointer, or the next variable, does not access anything new. It accesses a null. It's empty. And that terminates the linked list. You can think of a linked list again as a chain of values that tell you where the next value is. All we need to know all the values in this chain is where the first chain is. So in the stack, we have, say, a node top, or start, or whatever you want to call it. And this node top is going to point to the first node in the linked list. And that's it in a nutshell. So a linked list is just a collection of nodes. A node is a class instance, and that class contains a value and a way to get to the next node. And that's all a linked list is. Now here I've drawn what's called a linearly linked list, and it has next pointers or next reference variables to one node at a time. So there's only one link of nodes. You can make more than one node in a linked list. So if we have two nodes in a linked list, we get what's normally called a binary tree. So we have two nexts. Each one points to a new node. Binary trees are frequently found in storage containers because they are easy to traverse. And the easy way to traverse a binary tree is you look for a value here. If your value is less than a value, you go this way, less than. And if it's greater than the value, you go this way, greater than. And when you find the value, you stop. And when you fall off the end, you know the value is not there. And so that is a binary tree. B trees are pseudo-binary trees, or they're kind of like binary trees, but they're used in databases. They are used in databases, a B tree, and they make it reference quick. So if you have a database, you have millions of records in the database, you have to find one really quick. Each record has its own unique ID, and you're searching on IDs. And those IDs and the records they contain are stored in a B tree, which is a very quick way to find nodes. So why use a stack? There are really two reasons to use a stack. Let me do a clear. And we'll do a why use a stack. Stacks have very quick insert and delete. Stacks are very slow find. Binary trees have a fast find. And a fast insert and delete.
Bless you.
And that brings us to what are the basic operations on a collection. If you have a container of things that you're putting things in and finding things, we need to put something in, that's insert. We need to take something out and throw it away, that's delete. We need to find it, that's the find. And so for any collection, you're inserting a lot, you're deleting a lot, and you're finding a lot. You'll choose the structure of your collection. Is it an array? Or is it a linked list? Based on what you want to be fastest. And later we're going to talk about efficiency when we get into the sorting routines. That's coming up next week. Okay, let's take a look. Any people still waiting on their eclipses to load?
Yeah.
How many people? Raise your hands, please. One? Okay, all right, so we'll get started on this. So let's get started. So I'm going to bring Eclipse up. My Eclipse is ready, except I don't have a project yet, so I'm going to create a new project. I can go to File, New, Java Project, and this one we're going to call it the Stack Demo. You can call your stack. I'm going to call mine Stack Demo. All right, so now I have a new project called Stack Demo, and since this stack, I'm going to create a class for the stack. I need to exercise the class as well. I need to test it. So I need a tester class, and I need a stack class itself. So I can create a new class and call it the stack class. So new class, and I can call it my stack. I can call it my stack so I don't mess up or confuse the compiler with Java's stack. So my stack is the class that we're going to create. And the other thing we need in this is the driver. So I can create a new class, and this is the my stack driver, the my stack test. So we'll call it my stack test. So whenever you're working with classes, you must test them, and so you'll need to make a class to test them. The class that you're making itself, you may or may not, if you want to, put the actual tester inside the class. In this case, I've separated the two. The class I'm creating called myStack will not have a tester in it, and my main will go in myStackTest.java. So let me make my main to do the test. I always like to start by making the test first. It is a public static void main. Actually, I should ask you, what do you type next? I'm making a main. How do I make main? String args, exactly. String what args? Square brackets. So args is an array of strings. And here we want to test the myStack. I'm hearing talking. Shh. Do you want to see this demo or not?
Yeah, yes, please.
Okay. Thank you. Okay. So we're just going to say system .out.println, we're going to announce the test. Hello, system out. Hello, hello. Come on, catch up. There it goes. Println, and we're just going to out the test. This is testing my stack. That's all we're doing right here. All right, so let's run this and see what happens. This is right now, it's just a hello world. It should say testing my stack. And if I have all my things right, there it goes. Okay, so let's look at the stack itself first. And we'll do a little design work. So I need to create a linked list. A linked list stack. And this linked list stacks will store doubles. And it will do an insert, which I called push. And it will do a pop, and it will do a size. And let's use Java's convention. So instead of a capital P for these functions, we'll make them lowercase. So we'll make them camel case. What else? We'll do an empty. We'll do an empty. And there's some other things we'll need. We'll need a copy constructor. And we won't need a destructor, but we will need a copy constructor. If this were C++, we would need a destructor. We don't need one. Don't need a destructor. Okay. So the first thing we need when we create this thing is we need a node. And inside my MyStack class, I'm going to create another public class. Public class node, and this node will tell me what's in the class. I need a double value, and I need a node next. And when we create this thing, node, it's going to give us value equals 0.0 and next equals null. Now I don't need to write this. If I do not initialize value, the default initialization is 0.0. If I do not initialize a class variable, remember node is a class, next is a class variable or an instance variable. If I do not initialize it, it initializes it to null. And so here, this default constructor is superfluous. I don't need it. I also want a node constructor that takes a double. So I'm going to make another node constructor taking a double, v for value, and all it does is it sticks this value in to the value. So value equals v. I want to make the double value private, and the next node, actually I better not do that. Let's make them public. For now. We might make it private later. So in making the node, if I go back to the pretty paint I made, we are making, do I have the brush going? Here's the brush. A node. A node has a value and a next. And so we need two variables, one to hold the value and one to point to the next node. One to hold the value, one to point to the next node. Actually, let's make this private and see if I get into trouble. Actually, I think that's going to get me into trouble. Well, we'll see. Okay, now we have the stack itself. In the stack, we have a private top of the node. It's a node. Oops. We'll call it top. Or root. Let's call it root. Root's better. And root will point to, or reference, let's call it reference. Reference the top of the stack. Let's compile this and see what we get. It should still run. It should still be my, what do you call it? My hello world. So the next thing is to make my constructor work here. I have my print line testing my stack. I need to create my stack. My stack, mstack equals new my stack. And we'll try printing it and see what happens. System.out.println mstack. This looks like it's going to run. When we run it, it gives us a print for my stack, but it uses the toString of the object, Java's object. And the toString of Java object tells you the class instance that you're printing, and then a hash code for that instance. This is not what we want to see. So when we print the stack, can someone tell me what you would want to see if we printed a whole stack of things? What would you want to see?
Chickens.
Chickens? So if we print a whole stack of doubles, what format would you like to see it in? What format? What do you want it to look like? Do you want it to look like this, a square bracket,
Chickens that look like cows.
number, comma, space, number, comma, space, number, comma, space, and so on? Square bracket, you want it to look like that? Or somewhere different? Like this? You like that? Okay, so we're going to make our toString do that. Can someone tell me what is the syntax of a toString? Public, string, toString, then what? Brackets, curly brackets. String, string equals, let's call it bad my stack. Yes. Return ret string. So here we have a stub. When we run it, my hash code should chain into a bad my stack. Okay, so now we're printing the string, but it's not printing right. Right, it's just bad my stack. So we want to print it right. Let's remove bad my stack. We're going to make it a blank. And we want to print this string up here. What's the first thing I print? What's the first thing I put into my return string? I have it highlighted. A bracket and a space. So the return string equals bracket space. So let's make this bad string here anyway. Then what's next? A bunch of numbers. Let's do the back end. What's the back end look like? So I have to do stuff here. Do stuff here. What's the last end of it look like? Space in a bracket. Ret string equals space in a bracket. All right, let's run this and see what happens. Oopsie. I got something wrong. What did I get wrong?
You did plus equals.
Plus equals. No, that's right. Empty. Okay, it's working, right? We're printing everything. Do stuff here. So it looks like my test passes, right? I've created a new thing, and test passes. I did not announce my test. So let's go back to the test and announce what I'm doing here. And I just did a constructor, default constructor, and mstack. And when we run that, it now announces the test. I've run the default constructor. It is empty. That's perfect, right? Everything's working.
Yeah, that's just what else.
So the next thing I need to do is I need to push something inside, right? In order to print something, you need to be able to push stuff inside. And push is the function that does that. So let's look at push. So I'm going to delete this garbage again. Where's my selector? Image? Select. Here we go. So when I have a brand new my stack, my stack has this root in it, and root points to nothing. And I want to push a new value in there. So I want to put a value on the stack. When I'm done, we'll have a new node with the value in it, and it will point to nothing. And so to do that, we need 3 steps. 1, make a new node. Is there a typer here? It'd be easier to type. No. Shapes, brushes. Ah, here we go. All right. I need to, 1, make a new node. Can you see this, or is it too tiny? Zoom in. Yes, I can change the size. How's that? Can you see it? Still too tiny. How's that? Okie dokie. Okay, 1, I mean to make it a nude. No. I'll make a new node. Then I need to, what do I do next? I made a new node. It's empty. So I have an empty node. Put a value in it. Then what do I do? I need to point it at the old nodes. Then what do? Then I point root at it. So let's look at these steps. Let's look at these steps. Text, good enough. Home, image, select, go away. 1, I make a new node. 1, I make a new node. And root points to nothing. So far so good, yes? 2, I put a value in the new node. 3, new node still points to nothing, and root still points to nothing. 3, I point the new node at the old nodes. I'm going to run out of room here. I'm going to go over here for 4. So the root still points to nothing, and the new node with the new number in it, 3, is going to point to the old nodes. Currently, they're both are nothing. And then 4, point the root at it. So the root is now going to point to the new node with 3 in it, and the new node is going to point to nothing. So here's the steps again to add a new node. Create the new node. Put a value in the new node. Point the new node at the top of the stack. Point the stack holder at the new node. And we've effectively inserted a new node at the top of the stack. So let's write down the steps in our push function. So we need a push function. Here's my, let's do the test first. We need to do a push. So I can do mstack.push. Push, of course, does not exist. We're going to add a value to it, 2.53. And then we're going to print it. System.out.print line pushed. Oh, we're going to push a value. Plus double value val equals 2.53. We're pushing the value. And we push the value. And we print the new stack. All right, so let's look at the tester. Here we have a test. I'm calling a function I have yet to make called push. And push's job places the passed value on top of the stack. So here's value I'm passing. It's a double because this is a double stack. I set the value of the value to 2.53, and I push it. Then I print what I did. I just pushed the value onto the stack, and I print the stack. This will not run because push does not exist, so let's fix push. How much time do I have? I'm about a half hour into it. So I need a push. Let's put push after the to string. Can someone tell me what is the syntax of the push? How do I write my push? I want to do this. How do I do that? Public something push double push push. Then what do I go in here? Isn't it another double? Value. All right. What's this double for? What's the return type for? Why is it there? We don't really need it, do we? Let's make that void. All right, so now this public void push does nothing. I can do save all, but we note that now I can run this and see if it works. So I run it, and it says push 2.3. Nothing happened. It's broken. But now my test is trying to show me that it's broken, right? My test is saying, hey, it's broken. So let's fix it. Okay, what were the 4 steps of push? Step 1, what do I do? Do you remember? Don't remember? Let's take a look. What do I do for step 1? Make a new node. We have it right here, right? Make a new node. Put a value in it. Point at the old nodes. Point the root at it. Make a new node. Put a value in it. Point it at old nodes. And point root at it. All right, let's do that. How do I make a new node? How do I do that? What is a node? Okay, ladies and gentlemen, please do not use system settings. Please do not play Roblox. Please do not play, what's the other one? Bullet Force. Please do not even search those names.
Why did you lock up?
I was saying.
I think that thing's broken.
Dr. Schick, expose them. Expose these.
All right, let's see who we got here.
Hey, no.
Why is it quad?
Nah.
All right, I'm going to lock everyone. And let's save the exposure for later.
Oh, he turned flame now.
Because yeah, everyone see who would be naughty on the YouTube. Let's not do that.
Yeah, do it live.
Do it live. Yeah, no.
Who would be naughty on you?
Only naughty. Okay. How do we make a new node? We just do it.
I like it.
We already defined the new node up here, public class node.
You have to import it, right?
No, it's actually owned by MyStack, so MyStack sees it. What do I need? How do I make an instance of a class? What is root? Root is an instance variable. How do I make an instance variable? I want to make an instance variable for a node. How do I make any kind of variable? How to declare any kind of variable? Private. Although private will not work for a... actually, it will. No, it's mad at me. It doesn't like private. Because it's a local variable. Someone said it. Call the constructor. Node. I'm going to do 2 things at once. Val. I have a node constructor. How do I call a constructor? What do I need in front of the constructor itself? What? Reserved word. Nope. This, nope. Super, nope. I'm creating a new instance. All right, let me step back 1 step. How do I make an instance variable? New, exactly. Someone just said it. New. New goes right before the constructor. How do I make an instance variable? We did one on line 26. We don't need private because it's a local variable.
Just give it a name.
Just give it a name. What do you want to call it?
Steve.
Steve. Okie dokie. Our instance variable is called Steve, and Steve will get the new node. What kind of variable, what type of variable is Steve? It's a node. There we go. Node Steve. Steve gets a new node. I'm going to pass value. Here, remember we made a constructor to set the value of the node. The constructor to set the value of the node is right here. And it takes the value and sticks it in value. So we've done steps 1 and 2 in one step right here. Steps 1 and 2 are done. Okay, what's next? Number 3, pointing at the old node. How do I point Steve at the old node? Does Steve have members? And is one of those members next? This is not going to work out. It's going to get mad. Equals root. Now it gets, oh, it worked. Well, look at that. So let's look at this. Steve has 2 parts to it. Steve has a value and Steve has a next. So we look at the node has a value and the node has a next. Steve is a node. So Steve has a value and Steve has a next. We've put the value in when we use the constructor to make Steve. And now we're putting the next in by pointing it at the root. So when we do that, both Steve and the root will access the same next node element. And that's step 3. What's the last step? How do I do that? Root, point root at it. How do I do that? Point root at, in this case, it is Steve. How do I point root at Steve? Root equals Steve. And this is all we need with the push. So let's see what happens here. Right, we should put something in there. Maybe we'll see something happen. It scrolled off to get mad at us. Whoopsie. What's this? Declaration. Go away. It's still broken. What's wrong? Line 33. Two-string isn't working. So in the two-string, how do I print everything? How to print every double in the stack. How do I do that? So let's talk about iteration. Does someone know how to iterate through a stack? No, I see lots of no's. All right, so let's go back to the pretty picture stuff. Where is it? Here we go. So we're going to iterate through a stack. I'm going to erase everything. And I'm going to draw myself a stack. All right, in a stack, I'm going to just use circles now. A circle points to the next thing. A circle points to the next thing. A circle points to the next thing. And at some point at the bottom of the stack, we have a null. And we have root at the top. And root points to our top guy. And we want to walk through. Shh. Turn off the noise. So is this the right size? It is. We want to walk through the stack, printing doubles, and moving on to the next node. How do we do that? Any idea?
Can you put it into an array list?
An array, we could put it, but that's cheating. We want to use our stack. Right? We could do this all in an array list. An array list is a list that Java has made for you already. And it does everything as perfect as you can ever get it to work. So once you know how things work, there's no reason for you not to use Java's array list. But in this case, we're making our own stack. I can move this up a little bit.
So array lists are legal. I mean, not legal.
In my stack, in what you're doing this week, array lists are illegal. So you must make your own stack, and you must walk through your own stack, and you must do your own calculator which uses your stack. So we're going to make a postfix calculator. So we need to walk through the stack. And walk through, right, it says walk through. Let me go back to brushes. Walk through suggests that you're going to do some kind of loop. Yes? So what kind of loops do we have? For, what else do we have? Do while and while. Of those 3 loops, which do you think is best for walking through the stack? Why 4? Depends on how you use it. So do we know how many elements are we going to find in any stack? No, we don't know how many. Is there a way to tell us how many by just looking at the stack? All we see is root. We don't see what's in there. In order to sit there, we have to like go through and count it. I suppose we can go through and count it, but that sort of defeats the whole purpose of this loop, right? So for do while. Do means do it first and then keep going until something happens. Or while. So we're between do while and while. How many people think do while is the right one? We want to check to make sure there's something to do first before we can do it, because root could point at nothing. And if root points at nothing, there's nowhere to go. How do you know if there's somewhere to go?
So while has the best duration.
While has, well, in this case, while is what you want. You could do a for loop, because all for loops really are while loops in disguise. Shh. But the while loop actually fits. We're going to look for a marker that tells us we're done. Right, there's a marker that tells us, let me put it in a diamond, right, instead of a circle. Here's a marker that tells us we're done. Here's a marker that tells us we're done. So we're going to look for this marker. What is this marker?
No.
Null. We're going to look for null. So while we do not find null, do something. So that's what we're going to do. Walk through the stack. While we do not find null, do something. Print the double that's there, right? We found something, right? It's not null. Move on to the next one. Is the next one null? And so on. So what kind of thing changes its value all the time? What kind of thing that we have in Java, we have variables and we have methods, changes its value all the time? Or we have, what is the other thing called? Literals. So we have literals, we have value or variables, we have methods. Which one changes its value all the time? Variables do. So we need a variable. So let's go here. We need a variable. Need a variable to look for null. So what kind of variable would that be? What type? A double? We're going to look at what root points at, or root references. So what kind of variable is the same as root? A node. We're going to make a node. We're going to call this the looker or the temp or the indexer. We'll call it indexer. Or better yet, let's call it the iterator. It's not a real iterator, but we'll call it iterator. And it starts at what? Where do we start looking? When we start looking, where do you want to start? Root. So we're going to start at root. Where did my pointer go? The pointer's gone. Hello? Oh, there it is. It's tiny. We're going to start at root. So we start at root. And here goes our while loop. While iterator is not equal to what? No. Then we do stuff. Right, do stuff. What kind of stuff do we want to do?
Bro, come on.
I got code.
What do we want to do? We want to print the double.
Yeah, we would want to, but
System, I'm sorry, put it on a string. Ret string, yes.
no, don't.
The computer locked again?
Yeah. You are vegetable.
All right, so I can just unlock it.
You are a vegetable.
What's the
There we go. Okay, but how much time do we have? We have like 10 minutes. Okay, we're doing good. Ret string plus equals the double that's here. How do I get to the double? How do I get to the double? Or what does our iterator have? How do I find out what's at the iterator? What do I do? I do a period, member access operator. What do I do? Period. Tells you what's in there, right? An iterator has a toString, has a next, has a value, has an equals, has a get class, and so on. It has a value. Where's the double? It's in value. What else do I need to print? Right, I printed this. What's this thing here? Comma space. When do I print comma space and when do I not print comma space?
Between every
So between there has to be another value to print comma space. How do I know another value is coming?
If it is equal to no.
If iterator dot next, I'm sorry. Yeah, iterator dot next does not equal to null. That means there's another value. Then ret string plus equals comma space. What's the last thing we do? Let's go look at our picture again. Walk through the stack, printing doubles. What's this last thing say?
Move on to the next.
How do I do that?
It has to be a return thing. Break.
All right, let's look and see what I'm pointing at. Okay, so here I'm going to point at a node, right? I'm pointing at a node. A node has a value on top and a next at the bottom. All right, now my iterator, I can call it IT, is pointing at this node. How do I get the iterator to point to the next node? No, not push. What do I have at the iterator? Where did my pointer go? Here it is. What do I have here that might point to the next node? What's this do? What's next do? It references the next node. So the iterator points at this whole node here. So the iterator has a value and a next. How does the iterator find the next node? It points at the next, right? So here, watch this. Iterator equals iterator dot next. And this will point it at the next node. All right, so let's see what happens now. See if we get a break. Now, you might have yours break. If you screwed up on something, it might break. If you don't have a null at the end, it might break, and so on. So let's see if we can get a break. Hey, did it work? Can we push some more and see what happens? Why not? Let's push some more and see what happens. So in order to push, all we need are three things. Control copy. Let's push 2 more times and see what happens. 3 and -2. All right, so here we push 2.53, it goes in front. We push 3.53, it goes in front. The 2.53 is still there. And we push minus 2.53, and it's still there. Yay, push is working. What's next? Want to do pop?
Can you look at your thing before for your tester again?
You want to look at my tester?
But instead of electrical, thank you.
Oh, you want to quit? You want to do the rest tomorrow? We're almost out of time. You want to do tomorrow?
Yeah.
Okay. So I'll give you a heads up for tomorrow, and then we'll do the rest tomorrow. So we've done push. We've done the toString. We've created the node. And we've created the default constructor for my stack. Right now it does nothing. All right, we don't have a default constructor. So root is null when we start. There are no nodes in the list. Our push is working. Our toString is working. Our toString does iteration. Right there's iterator 1, 2, 3. So these 3 lines, 45, 36, 37, 45, iterate through a linked list. And we have push. Push pushes the new node at the top of the list. And that's all we have so far. So tomorrow we need to do pop and size and empty. That's what we're going to do tomorrow. Okay, let's show you where you're headed, and then I will turn. Actually, I'm going to turn off the recording, and then I'm going to show you where we're headed. Bye.